the function that we're going to do today is hyperbola. So this is how an hyperbola function looks like. You probably have seen it. This is how it looks like. It's y is equals to 1 over x, and this is normally called the mother graph. This is the standard. This is where everything happens. This is just the basic graph, which normally in maths we called the basic graph, the mother graph, right? So I'm gonna sketch the graph in the next tab. Let me draw the mother graph. So you're gonna say y is equals to 1 over x. So this is how the graph looks, right? This is the standard graph where we have two asymptotes. The two asymptotes is y is equals to 0 and x is equals to 0. And basically the asymptote means is where the graph never touch. The graph never touched there. When you punch any value, when you want 0, it's going to tell you the fact that it's undefined, right? So that's the mother graph, and this is how it looks. This is how the mother graph looks. So moving to the general form of the hyperbola, right? The general form says y is equals to a over x plus q, right? Where now we're going to learn the effect of a, what happens when we have a different type of a, whether it's negative or whether it's positive, what does it do to the graph, and we're going to learn the effect of what? Q, right? So we had the standard graph, which is 1 over x, and now we're adding some new elements, which is a. So now we're going to play on the value of a, and then we're going to play on the value of q. Then we're going to see how each affects the graph, right? Before I go to the next slide, let's go and check how the effect of a changes the graph. So you see that the mother graph is in red, right? So now let me create another tab here, and let's see when we have, so we have y is equals to, let's say here a is equals to positive 1, right? Let's say now that we have y is equals to negative 1. What happens to the graph? Do you guys see what happens to the graph? What happens when a is positive is that your graph, the one in red, is going to be in your first and what? That quadrant. But when a is negative, your graph is going to be in your second and fourth quadrant. Does everyone understand how a affects the graph when it changes by just looking at what I just did right now? Is everyone okay so far on the effect of a?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, so you see that the mother graph is the one in red, right? And the next graph, which is blue, is when we change a, and a is negative, right? So that's what happens. So looking at that, let's go to the slides. It says the effect of a, right? They say the effect of a on the shape in the quadrants. When a is greater than 0, f of x lies in the first and third quadrant, which is just what I just showed you. Meaning in simple terms is that when a is positive, what happens is your graph becomes in your first and third quadrant, right? A is less than 0, f of x lies in the second and fourth quadrant, meaning that when a is negative, it lies in the what? In the second and fourth quadrant. The effect of q, right? What happens when we add q to the mother graph, right? So I'm going to take the mother graph, which is the mother graph is y is equals to 1 over x. Then if we say y is equals to 1 over x, and what happens is we add a plus 1. Do you see what happens to the graph? When we add a plus 1, this is the mother graph. The red one is the mother graph. When we add a plus 1, the graph's what? Moves up by 1 unit. Do you guys see it? The graph is going to move what? So see here, your new asymptote is going to be what? Your new asymptote is going to be positive 1. When we say negative 1, the graph moves downwards. Do you see the purple graph? So from the mother graph, which is the red one, it moves 1 unit down. Q moves the graph up and down. Is everyone okay with that? By just looking at the graph, from looking at the red graph, which is the mother graph, and moving it up, which is when we move it up is the green one, and when we move it down is the purple one. Is everyone okay with the effect of Q?
Yes, ma'am.
So then we move to the effect of Q, right? The effect of Q on the vertical shift. For Q is greater than 0, f of x shifts vertically upwards by Q units. For Q less than 0, f of x shifts vertically downwards by Q unit, right? Then it says the horizontal asymptote is for y is equals to q, and the vertical asymptote is for y-axis, which is the line x is equals to 0. So the first example is this. So we're talking about the effect of A and Q. So we have the first graph, right? The first graph is this is the mother graph, if you guys see it, right? Then the second one is y2, which is we're going to fill here. I'm going to fill it first. We're going to talk about the value of q, the effect of q, and the value of a and the effect of a, right? For y2, what's going to happen is we know the fact that q, there is no q. So we know that q is equals to 0. So there is no q, and the effect of q, so there is no vertical shift. So I'm going to say there is no VS, no vertical shift. Then the value of A, so we know that A is going to be equals to what? In our case, it's going to be equals to -4. This is equation 2 that I'm looking at. And the effect of A, what's going to happen is it's going to lie in the what? In the, since it's negative, it's going to lie in the second and what? Fourth quadrant. It's going to lie in the second and fourth quadrant. Is everyone okay on how I feel this table? Does everyone understand?
Yes, ma'am.
Okay, so I'm going to give you guys 2 minutes to do y3. Then I'm going to give you time 3 minutes, and I'm going to give you another 3 minutes to do y4. Then we're going to fill it together. So your timer is going to start now so that you guys are going to tell me the answers on how to fill this table. So in total, I'm going to give you guys 6 minutes.
-2.
So it's -2, right? And what is the effect of q when it's -2? What happens?
There's a vertical shift.
Yes, there's a vertical shift. Where does it go? Does it go
2 down, 2 units down.
Downwards, right? So let's just write downwards because my table is not. So it's going to go downwards. So what is the value of A?
It means that the function lies in quadrants 2 and 4.
So before I move, right, does everyone understand? Does everyone understand the effect of A and the effect of Q on the graph? So that I just don't move on and people don't understand. Is everyone okay?
Yes, ma'am.
So now, introducing basically a general form of the graph, of the formula, right, of the hyperbola. So now we're going to talk about the, the vertical, the left and right shift, right, which is P. So let's see how P is affecting the graph. So I'm just going to deal with P now, right? So let's say P is -1. Do you see what happens to the graph? The graph moves what? It moves to the right-hand side. Do you guys see it? So when P is negative, which is the green one, so when P is, it's negative, right? It's going to move onto the right-hand side, right? And let's say P is what? Positive now. So when we say X is equals to 1 over X plus 1, which is the black one now. Do you see where the graph is going to move what? On the left-hand side, right? For P greater than 0, the graph will shift left by P units. So it's going to move left by P units. And they say for P less than 0, the graph is going to move what? It's going to shift. I'm going to do the first one from the graph so that you guys can see it, what I was explaining about the P. Then I'm going to do the second one here again on the graph so that you can see what I was saying too, right? So we have the first one. We know the fact that that's standard, right? So we know the fact that we're going to ignore the intercepts. We're going to ignore the asymptotes. We're going to ignore axis of symmetry. We're going to ignore everything and we're going to look at basically just P, right? So I'm going to write my answers in black. So what's going to happen is if 1 over X, there is no effect, because P is 0, right? So everyone understand the fact that here in the first one, there is no effect because of P is equals to 0, right? So let's move to the second one, right? Which is they say X minus 2 to the right-hand side, right? It moves to the right. So meaning if this was positive, it was going to move to the left, right? So I'm going to give you guys 2 minutes to do Y3, only the effect of P, and another 2 minutes to do Y4. Don't do the other things, just only do the effect on P. So I'm going to give you guys 4 minutes in total. Y3, which side does it move? Does it move to the left or right? P, looking at P. What happens to the, what does P do? What is the effect of P?
It moves the function to the right.
Right. And the last one is going to be obvious. What happens?
It moves the function to the left.
So everyone is okay on how P affects the graph, right? You know the fact that there's going to be a time where the combination of everything, right? So let's combine one graph where we move it to the left. First, we flip it, which we change the quadrant, meaning A is negative. So let's create a graph where A, I'm going to write it in blue here, where A is negative, right? Then it moves, maybe it moves to the right. So it moves to the right, moves to the right, meaning P is what? P is negative, right? So P is less than 0. So meaning P is negative, and it moves up. So it moves up, upward, meaning Q is what? Is positive. So Q is going to be what? Positive. So just any graph, let me say the fact that y is equals to negative. So it's going to be -1 divided by x. P is negative, so it's going to say plus -2. Then we're going to say plus 4, right? So let's sketch this graph on my graphing calculator, right? So it's going to be -1 divided by x minus 2 plus 4. And see when everything happens, what happens to the graph, right? So when everything happens, this is what happens. If we say y is equals to -1 divided by x. So you see the fact that the graph changes, right? It changes from it changes from the first and third to the fourth and to the second and fourth quadrant. And we're gonna move it how many units? 2 units to the right. So the graph moves to the right, right? Then what we're gonna do is we're gonna move it upwards by 4 units. You see what happened to the graph? Let me take away this one. Do you see what happened to the graph? It changes positions by just moving it by slowly and flipping it. So now we're going to talk about the domain and range. Does anyone know what's the domain and range? Anyone? Then I'll explain later. Just give me a while, guys. What's domain and what's range? What's domain, guys?
Domain is all the x values.
Okay, in the function. And anyone? What's range? Anyone?
Range is the y value.
Okay, so range is all the y values, right? So we know the fact that domain, right, is all the x values in the function, right? And range is what? All the y is all the y values in the function. So everyone is okay, right? What's domain and what's range? So here, since we have asymptote, our asymptotes affect how our range and domain is, right? So I'm going to give you basically functions or restrictions. Yes, I'm going to give you restrictions that you need to solve to know how you're going to write your domain and range. So let's start with our, let's start with our domain, right? So we know the fact that for the domain, so we know the fact that for our general formula, the general, we have A is divided by x plus P, right? Plus Q, right? So we know the fact that P is our asymptote. We know, if you guys didn't know, we know that P and Q are our what? Asymptotes, right? Asymptotes. So that's where our graph does not touch. So we need to solve for our P and Q respectively in our graphs when we're dealing with an hyperbola, right? So dealing with that for our domain, right? What we need to do is we need to solve for P. So we're going to solve for P. What's going to happen is we're going to say that P plus P, X plus P is equals to, it's not equals to 0. So because we know the fact that if anything is 0 here, our function is going to be undefined. Anything divided by 0 is going to be what? Undefined, right? Does everyone understand that? So we're going to solve for x, right? So anything is going to be undefined here. So you're going to say x plus p is not equals to 0, right? Then what you're going to do is you're going to solve for x. You're going to make x the subject of the formula. So you're going to say x is not equals to -p or whatever value in respective in our function what it is. Domain, right? Domain. So you're going to say what? X. Then you're going to say x is an element of real numbers, meaning the fact that x exists everywhere, but it does not exist here when whatever the p value is. So you're going to say x should not be equals to -p in our case of the general formula, right? Then dealing with our range, we're going to do the same thing. With range, you're going to look at q. So p affects domain and q affects what? Our range, right? So for range, what you're going to say is whatever the value q is, y should not be equals to that. So y should never be equals to q. So our range, how you're going to write it, is going to be like this. You're going to say this. You're going to say y dot semicolon. Y is an element of real numbers. Then you're going to say this. Y should never be equals to q, right? I'm going to do a general formula to explain this. So this is just the general way. So for the domain, it's going to be always like this. X is an element of real numbers, but you're going to put a restriction, the fact that it can never be equals to p. Then for range, it's going to be always like this, that y is an element of real numbers, but it could never be equals to q. So let's solve a question, right? Then I'll give you guys one to solve it so that you guys can see it in a number form. Example. So we find, for example, they say y is equals to, so for example, we say y is equals to 2 over x plus 1 then plus 2, right? And they say find domain and range, right? So first we're gonna solve for p. So we know that p is gonna be x plus 1 is equals to 0, right? We're solving for p. So what's gonna happen is we're gonna say x is equals to -1, and we know the fact that this is p. -1 is, right? Then we're gonna solve for q. We know the fact that q is gonna be this, right? So this is gonna be our domain, and q, which is 2, which is gonna be y is equals to 2, is gonna be for what? Our range. So this is gonna be for range, right? So we know the fact that this is always domain, deals with domain, and this deals with range, right? Then what we're going to do is we're going to write domain, then we're going to put a colon, we're going to put a bracket. Always we're going to say x, semicolon, x, semicolon, so you guys can see it. X is an element of real numbers, meaning that x exists everywhere, but x can never be equals to -1. Then for our range, looking at this one, which is p. Then for our range, what's going to happen is we're going to put a semicolon. We're going to say y, semicolon. We're going to say y is an element of real numbers, but it can never be equals to q. So we're going to say y can never be equals to 2. So you're going to put this to see the fact that that's what we need to put there. Does everyone understand on how we find our range and domain? Or you guys are a little bit confused? Are you guys okay?
Yes, ma'am.
Okay, so let me give you guys a question so you guys can do it. So let's do this one. I'm going to write it in blue here. So it's going to be, let's say they give you guys y is equals to 1 over x plus 4 plus 2. And they say find domain and range.
Hello.
Right? So I'm going to give you guys 5 minutes to do it, and we're going to do the solution together. Are you guys done?
Yes, ma'am.
Okay, so we know the fact that p represents where the graph is not going to touch in the x-axis, right? So we know the fact that x, in our case, p is +4, so x plus 4 is equals to 0. Let's solve it. So x should be -4. So the graph should never touch at what? At -4, right? Does everyone understand that part? The fact that the graph can never touch -4.
Yes, ma'am.
Yes. Then for p, the graph y is where, for q is where the graph should never touch at the y-axis. So y can never be equals to +2, right? So what we're going to do is we're going to write our domain. So we're going to write our domain, which our domain is going to be x, colon, is going to be x is an element of real numbers. Then we're going to say what? X should never be equals to -4. Then we're going to have our range, which is our range is for y. So y, colon, y is an element of real numbers. And we're going to say y can never be equals to +2. Does everyone understand? Is everyone okay?
Yes, ma'am.
Yes. So a reminder that I want to say, right, is that for p, for domain, we don't take this the way it is. We need to always equate it to 0 to solve for x, right? But q, you can take it the way it is. So remember, for this one, we need to equate to 0. But this one, we can take it the way it is. So everyone is fine with that. Now we're going to move to intercepts, right? And how to solve intercepts. X and Y intercepts. Right, so for x-intercepts, to find x-intercept, we let y equals 0, and for y-intercepts, we let x equals 0. So I'm going to do the one that I was doing, the equation that I was doing. Then you guys are going to use the same equation that I gave you to solve for the X and Y intercepts. So the equation that I had is this one, which is, this one is Y is equals to 2 over X plus 1 plus 2, right? So we're looking for the X intercept. So I'm going to say X intercept, let Y equals to 0. So taking our equation, where I see Y, I'm going to put 0. So I'm going to say 0 is equals to 2 over X plus 1 plus 2. Then I'm going to solve for X, right? So I'm going to take the 2 to the other side, so it's going to be negative 2 is equals to 2 over X plus 1. Then this is negative 2. This side is the same as saying divided by 1, because of negative 2 over 1 is the same as 2. So I'm going to take that, then I'm going to cross multiply. So when I cross multiply, I'm going to multiply this and this. So it's going to be negative 2 open bracket X plus 1, because it's negative 2 multiplied by this. Then I'm going to say equals 2. Then I'm going to equate this and this. So it's going to be what? 1 multiplied by 2. So I'm going to distribute everything. So it's going to be negative 2 minus 2 is equals to 2. So when I solve that, it's going to be, I'm going to take the 2 to the other side. So it's going to be negative 2x is equals to negative, what you call this is going to be 2 plus 2. Let me move this here. Let me erase this one. So I'm going to move it here, right? So it's going to be negative 2x is equals to what? Positive 4. Then what I'm going to do is I'm going to divide both sides by negative 2, because I want the x alone. So this and this are going to cancel out. Then x is going to be equals to what? To negative 2. So the coordinates for this is going to be what? It's going to be negative 2 and 0. So this is either going to be the coordinate for the x intercept. So now I'm looking for the y intercept. As I said that for y intercept, you're going to say let what? Let x equals 0. Then now wherever we see x, we're going to substitute 0. So we're going to say y is equals to 2 over what? 0 plus 1 plus 2. Then this is going to be the same as 2 divided by what? 0. It's going to be 2 divided by 0 plus 1 is 1. Let me not write that. It's going to be the same as divided by 1 plus 1, which is y is equals to 2 plus 2, which is therefore y is equals to what? 4. Then the coordinates for that is going to be what? Since we said let x equals 0, so it's going to be 0 and 4. So this is going to be your y intercept. That's it. I'm going to give you guys this question and give you 5 minutes. I'm going to give you 6 with this one. So we're going to have y, the one in blue, right, is 1 over x plus 4 plus 2. So I'm going to give you guys 6 minutes to do this. So your 6 minutes starts now. So let's solve it, right? So for x intercept, right, we need to let y equals 0, right? So wherever we see y, we're going to substitute 0. So it's going to be 0 is equals to 1 over x plus 4 plus 2. Then we're going to solve for x. So we're going to take the 2 to the other side. So it's going to be negative 2 is equals to 1 over x plus 4, right? Divided by 1, so we can cross multiply. So it's going to be negative 2 multiplied by x plus 4 is equals to 1 multiplied by 1, which is 1, right? So we're going to distribute the 2 inside. So it's going to be, then we're going to distribute the 2. So it's going to be negative 2x minus 8 is equals to 1. Take the 8 to the other side, because we want the one with x on one side only. So it's going to be negative 2x is equals to 1 plus 8. So it's going to be negative 2x is equals to 9. So move it here. What's going to happen is we're going to divide both sides by here. Divide both sides by negative 2, because we want x alone. So it's going to be negative 2x divided by negative 2x is equals to 9 divided by negative 2. What's going to happen is not negative 2x, sorry, by just negative 2. So the negative 2 are going to cancel out. So x is going to be equals to negative 9 over 2. So meaning your coordinates is going to be negative 9 over 2 and 0. Did everyone get this as their x intercept? Did everyone get this?
Yes, ma'am.
Yes.
Okay. So everyone is okay on how you get your x intercept, right?
Yes, ma'am.
Yes. Okay, cool. So let's move to your y intercept. So y intercept. So we know the fact that for y, we need to let what? X equals to 0. So if we let x equals to 0, wherever we see x, we substitute 0. So it's going to be y is equals to 1 over 0 because that's where x is, plus 4 plus 2. Then we're going to solve this. So it's going to be y is equals to 1 over 4 plus 2. Then if you punch this into your calculator, what you're going to get is 9 over 4. So our coordinate is going to be 0 and 9 over 4. Did everyone get this as being their y-intercept? Hello?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so everyone understands, right, how to get your x and y intercept?
Yes, ma'am.
Okay, cool. So have a good day and bye.
You too, ma'am. Bye-bye.
Bye. Bye.